Hello? Did you hear me at the back? Okay. Good morning. I hope you had a good keynote session by Riza. So today I'll be talking about building cloud-native apps with .NET Core and Kubernetes. You would have seen some of the salient features across .NET, and we'll focus more on the .NET Core part here. And let's also see how does it work with Kubernetes. So, since there are many things in Kubernetes, .NET Core as well, and Cloud Native, we'll try to focus on some of the key areas. One of them being the health checks. Second one would be on the Docker images and endpoint routing, as well as worker service, which are new features available, as well as the configurations specifically for Kubernetes support. So let's start with the first one, which is health checks. And let's try to understand why health checks are important. If you work with, let's say, microservices, or even with deploying applications from cloud, you would have seen that things like load balancers, they do health checks, and they look at the status of your application, and based on the status of your application, they can decide whether to route the request to some different server or different instance of the app. So in .NET Core, there is a default setting or a method provided, which is to enable the health check. So you have at the service level support for adding health check with just one method call. So before .NET 3.0, you had to enable this, you had to provide your own health check endpoint, and you had to manage this. Now it's all built into the framework itself. And to enable this, you need to import this health checks package, which is available in the diagnostics. Apart from the health checks, you also can define your own endpoint. So once you have enabled the health check in your bootstrap process or startup.cs file, you can say which endpoint, like in this case, we are saying map health check to an endpoint called health. So that is what your monitoring tools can then start querying to know what is the health of your application. This is for like web applications. If you are deploying, let's say, databases as containers, so you can enable health check at the database level itself, and this again you get another method called add database checks. So you can do things like you define a connection string, and this connection string will be called periodically to say if the application can connect, or if a service can connect to that particular instance of the container. So when it comes to health check, there are basically three statuses given by default. One is healthy, unhealthy, or unavailable, or degraded. So you can write your custom logic. These are the default ones. You can override this. You can provide, let's say, you have a custom matrix based on which you want to report the health check. You can override these methods, or you can override the response that is given as part of the health endpoint. Next one is Docker images. So this health endpoint I'll show you in the demo. Let's look at Docker images. One of the major benefit of images is with .NET 3, there is a reduce in the size of the image, the base images which are used. So how many of you have used Docker? Okay, quite a few. You know how the image sizes work, right? Or how does Docker work basically? You create an image, you build your application, you package it as a container, you push it to a container registry, and then you download it into your deployment environment. So if the image size is big, you can imagine the amount of time it takes to push the image to the registry and the amount of time it takes to pull this. That's why it's very important, and you see this trend not just in .NET, even Java is trying things like Quarkus, other programming languages. They are trying to limit the size of images, the base images that are provided. So in this case, you can see that if it's a Debian-based image, initially it was 261 MB with 2.2, .NET Core 2.2. If we go to 3.0, it is almost 60% or 60 MB less with 207. For the Alpine-based image, we have again similar reduction in size, about 60 MB. These are for the images which are used to build the application. So these have all the build tools and the things like compiler. But if you use a runtime image, it is again much smaller, which is 100 MB smaller compared to the previous ones. So we can quickly have a look at this in the demo itself. So okay, so you can see the first image which was created about 10 hours before. This is 190 MB or 192. This is .NET Core worker, and web is about 207 MB. Whereas I had the older version of this, so you can see here the web is about 250 and the API was similar in size. Similarly, the runtime image is about 189 MB here, and there was an older version of .NET Core which was more than 1 GB.
Your microphone's not on.
Sorry?
Your microphone.
Hello?
Is the temperature degree? Check is the temperature.
What?
Checking the temperature inside the mic may be the maybe out of measuring.
Yeah, I think it's okay. I'll try to speak louder. Can you hear me at the back? Okay. I don't get mic, but for recording. Okay. Fine. So you can see the older version. This is .NET 3, which is 689 MB. Hello? Yeah. So 3.0 .NET Core SDK is 689 MB here, and if I look at the previous one, 2.0, I should have much bigger set. Yeah, you can see here. 1.3, sorry, 2.1. This one, the build image. 2.2 GB. Yeah. So that's the difference in the image sizes. So one of the new things which is coming with .NET 3 is worker service. So if you're working with containers, or if you're working with .NET Core before, there was no way you could create, or there was no easy way you could create a long-running process like a service. So worker service gives you that ability to create long-running processes, and you can add a host. It adds a service which is of the type worker. So we'll see an example of this as well. But this worker service you can run in two modes. One in Windows. So if you want to run it as Windows service, you say use extension, which is Windows Service Hosting, and you add this use Windows Service method. So it makes this worker run as a Windows service. If you want to do the same with Linux, like systemd, you can say use a system daemon, and the package would be similar to using a systemd instead of Windows. So I have an example of this as well. Let's look at a demo of this. So let me create a demo on Linux. So I have a version of Ubuntu running on Windows subsystem for Linux WSL, and just go to the parent folder. Okay, so you can use the .NET CLI to create your project templates. So let's make sure that we are on 3.0 version. So on Linux I'm running .NET Core 3.0, and I can say what are the project templates available here. So in the new one, you have similar to the old version, you have this all the commands available: add, build server, clean, and all. So let's look at the new templates. .NET new and so you can see here that these are the different types of project which can be created using new command line. So you have the typical console, classic, lib. You can now create WPF application, WPF libraries, WinForms. You have the new worker template available here, and similarly you also have support for gRPC services. So you can create a new gRPC based service as well. So let's create a worker process here. I've already created, but just for the sake of the command to show, is .NET new, and I can say worker, and I can specify the output file or output path and what is the name of it. So based on this, it will create the project templates. I already have this created, so let me go straight into it. So you can see these are the files it creates. You have the worker.cs, for the moment ignore Docker file. Then you have program.cs, the CS project file, and then the two configurations, development.json and app settings.json file. So let's open this using Visual Studio Code. How many of you are familiar with Visual Studio Code? Okay. So what's happening here is when I open the Visual Studio Code, it's actually spinning up the code instance on my base machine. It's opening it on Windows machine instead of opening it in Linux. And I have a extension enabled which is for the Windows subsystem for Linux. So whatever I do in code, with the help of this extension, it actually persists the data or the files in the Windows subsystem for Linux. So I can use the same IDE, work with this, but I'm actually developing on the Linux environment here. So you can see that the background service or the service, it actually inherits from a background service process or class. It injects a logger by default, and it runs a sync process continuously, and it waits for a cancellation token. So as long as somebody doesn't send a cancellation token, this process will keep running. So to run this, I can go back to the command prompt and say .NET run. And you can see that every 2 seconds it's writing a message. So it's running as a service now. Now let's do one thing. Let's enable Docker for this particular worker and containerize this. So in order to containerize this, the process is similar to what we were doing before. I will use a base image, which is .NET Core Runtime 3.0 as the base. I put my source inside that at the .NET restore. I build. This is done as part of a multi-stage build. So initially I build using one version of the image, which is the build tools image, and then I publish it into a final version, which is into runtime image. So in this, it copies it into a final and makes it as a runnable. So if I have this, I can go and with the Docker support for Visual Studio, I can say build image. I can give the tag, and it tries to build on that particular USM machine or the Linux or Unix machine. And I don't have Docker running there, so I can't build it. So any idea how we can build this particular image if we don't have Docker running?
Most of those.
But I don't have any swag to give you. You can use Azure Container Registry. So even if you don't have Docker running locally, ACR provides a facility where you can use the Azure Container Registry to build your images. So I've already created a registry. So these are the commands which you use to create a container registry. You create a resource group. In this case, I'm creating it in Southeast Asia. The name of the resource group is demo.netconfsg. And inside that, I create an instance of Azure registry, container registry. This is just a basic SKU, and I enable the admin. And once I have it, I can build this particular Docker image onto that. So now this is publishing or copying the code from my Windows subsystem for Linux onto the container registry on Azure, and it does the build process as per that Docker file. And this will store the version of the image in container registry. So I've already built this. I will show you the output of this, but in the interest of time, let's go and deploy this version of the image on Azure Container Instances. So here I am inside my Azure subscription. If I go to Container Instances, I don't have anything running at the moment. So I can go to the container registry. So go to the resource group. Container registry. This will have a repository, and that repository will have the image. So I pick the latest version of that, and I say run an instance of this image. So I can give the container name. So let's say it's worker. It's of type Linux, and let's run it in Southeast Asia. and I'll need a public IP to access that. So now this will go pick up that version of the built image and go and deploy it. So while it deploys, let's move on to the next slides. So I'll come back to it once the deployment is done. The next feature is endpoint routing. So endpoint routing enables you to route or map a route without having to go through the whole MVC sort of middle tier. You don't need all that middleware if you're just writing services. So without having to create a view, you might just have a controller and which accesses your backend services. In such scenarios, you can just create an endpoint. So you say use routing, and then you define an endpoint here, and you can define what is the response. So you don't need to create a controller, you don't have to create all those things which were required in previous version of .NET Core. Next thing is configuration. Configuration is quite important in terms of microservices or even normal applications. And .NET, since even before .NET Core, the .NET version itself had very good support for configuration. We used to have, let's say, JSON, XML support, environment variables. When it moved to cloud, you had the app configurations. But with the instance of Kubernetes or orchestrator, managing your configuration becomes quite important. And when it comes to Kubernetes, you have two ways in which you can manage configurations. One is config maps, where you can just put a key value path. You can also manage secrets. So if you have anything that needs to be encrypted, secrets is the preferred method of using configurations in Kubernetes. So in this case, what we are doing is we create a secret from a file. So let's say in the demo, what I'll be doing is I have Azure table storage where the logs would be written, and the connection string to that is encrypted. So that is stored in a secrets file or a JSON file, and then I create a generic secret at the Kubernetes cluster level. So I don't have to inject the secret, or I don't have to store the secret on individual nodes. I store it directly at the cluster level, and then my pods can refer to this secret using the support for the secrets in .NET Core. So the way we do it is, in the container specification, we map a volume to secrets, and we create a secret named, let's say, app settings. And this is stored inside a mount path, like secrets inside your pod. So think of it like if you have a shared drive in Windows and you want to map it to, let's say, a particular name. You have Z colon, you want to map that drive as M drive or Z drive, and then you want to refer to a folder inside that. So this is something similar. You define a volume, and that you map to a volume inside your container. So using this, now the secret is available inside your cluster. In your program, you refer to it using the secrets path. So this is not stored on individual node or anywhere. This secret is available across the cluster. So even if your container, let's say today it's running on one particular node, it gets rescheduled onto a completely different node, this secret would still be available because we are referring to it from the cluster level and not from a physical node level. So let's look at this demo as well. So for this, I'll switch back to the normal Visual Studio, not the one running inside WSL. So here is the worker, which is actually looking at that configuration. So I'm injecting HTTP client and a configuration here, and using the configuration, it looks at a health endpoint, and it tries to see There is a service called web app. So I've created a just simple ASP.NET Core web application which exposes an endpoint for health. It tries to query that, and every 5 seconds it will try to look at the health of the application, and it logs this into Azure table storage. So it uses that secret where the configuration string or connection string to the Azure table storage account will be stored. It uses the storage account, and then using the logger, it writes to this particular table. Okay. So let's have a look at this demo. Okay, so before we move on to the second one, we can see that there is an instance of this first demo running. So the container has been deployed, and if we go down, we should be able to see the logs. So you can see the logs from that .NET Core worker which we created. It's being written to this particular log string. So this was the first demo where we created a worker inside Linux machine using Ubuntu, published it to a container registry, and deployed it to Azure container instances, all using the Azure portal. So the next one, I have instance of Kubernetes service running. So I've already created a cluster here. So you can see it's a 2-node cluster, and you can see what pods are running on it. Right now there is only one pod which is the web application running. So I will deploy the one which is for the worker process, which queries that health endpoint. So I have a deployment file here. I will go and deploy this. Okay, this has been applied, so we can go back to the browser and check. Almost done. 2 minutes. Okay, so we have all the pods deployed. Now even the worker is deployed here, and if the worker is running correctly, we should see some logs in the table. So in my storage account, this is the table where I'm writing. It's called hello worker, and if we refresh, we should see some records here. So this is being written every 2 seconds, every 5 seconds, sorry. 40, 45, 50, 55. Okay. And just to show that this is really working, I can go and kill the pod, which is the service, and we see the logs being written here. So I'm just deleting the pod which is running the web application. Just being deleted. And if I run the get pods again, you see that it's running within 90 seconds. This is because I have a deployment, and this is the way Kubernetes works. I have a deployment which says my desired state is I need to have one instance of the pod running. So even if I kill it forcefully, it sees that the pod is not running and it needs to have one pod running, so it instantiates a new one. So this part, we can go back to the logs and see that it was deleted and it was recreated. Demo effect. Sorry, when I was running the demo earlier, I could see that the pod was getting deleted and recreated. Some of those logs are not coming in this log right now. But anyway, that's what I had to show you guys, and that's almost the end of my demo. So we looked at the secrets configurations, we looked at the demo. So in case you want to learn more about Kubernetes, I usually refer this. This is called the 50 Days from Zero to Hero with Kubernetes. It's a collection of small videos as well as online links. Apart from this, specifically for .NET, there is a series of 80 odd videos which you can refer to. And if you want to find the source code, it's available on GitHub. So that's all from my side. Thank you. Any questions?
This works.
Yes, sure.
Here or
The slides are available online, so you can find them. The link is here. It's on SlideShare as well as speaker deck. Any question? Thank you.